Namaste. My dear students, we'll discuss one important problem today. Design a low-pass filter using Fourier series for the following specifications. H of F, capital F, is in analog, equal to 1 between 0 to 1000 Hz and 0 elsewhere. And sampling frequency given 4 kilo samples per second. Impulse response duration is 2.5 milliseconds. So this is the data given. Now since impulse response duration is given, the solution is Pi is equal to 2mt. Pi is this impulse response duration. So 2.5 into 10 power minus 3 equal to 2mt. So this T is 1 by 4000. Solve for m, we will get 5. When m is 5, what is m formula? M equal to n minus 1 by 2. So solve for n, you will get 2m plus 1, which is 11. So n is 11. Filter order is 11. So we find with the help of this. And we have to design a low pass filter in Fourier series, using Fourier series. So what is h of n general formula? This you have to remember. OMS integral minus OMS by 2 to plus OMS by 2 h of f and e power j o m t d o. But here what we are doing, low pass filter. For low pass filter, how limits will change? Its value is 1 from minus ohms to plus ohms. Within this range, its value is e power j o m t d o. So this is further equal to as per mathematics rules 2 by ohms integral 0 to g cos ohm nt do. Is equal to, this we have to simplify, 2 by ohms. What is integration of cos is sine ohm n t nt. And limits are from 0 to ohms. This is further 2 by ohms. Ohms is nothing but 2 pi fs. Sine, after substituting it will become ohms t nt n, t is nothing but 1 by fs. So fs cancel, this cancel, 2 cancel, we'll get sin. Here also 2, you have to substitute all the things. 2 pi, what is fc given? 1000. This is again n t by n pi. To simplify this further, we will get sin 0.57 n by n pi is equal to sin 1.57. If you bring the denominator also 1.57 n. So this factor extra we are taking 1 point, and already pi is there. Already pi is there. So this is equal to, I have to find h of 0. What is h of 0? Sin 0 by 0. So that is 1. 1.57 by pi, 0.499. So approximately like that, h of 1. H of 1 is what? 1.57 by pi in 1.5 1.57. But this is in radians. Select calci in radians. So simplify, you will get 0.23. All of you check this with your calculator. Then h of 0.0. H of 3 minus 0.106. H of 4 minus 0.00 of 5, 0.06. Out of 11, right side 5, left side 5, 10, center 0, total 11. So like that, these 11 values we come. Now from this we have to find the BI. What is BI formula? Of I minus E. What is M in our case? 5. So H of I minus, you have to find all these values. B0 is H of minus, H of plus 5 plus 5, H of minus 5. This is equal to H of minus 4. This is H of minus, this is H of minus 1. So what is B0 value? H of minus 5, which is equal to 0.6. Like that, B1. B1 is H of minus 4 is minus 0.0. like this we have to find. Like this we have to find all the values. B10. So B10. B10 is nothing but h of 10 minus 5 is 5. Is h of 5 value 0.0. Then lastly h of z. Is h of z formula equal to 0 to 2m. 2m is nothing but 10. And bi z power minus. So this you have to expand and substitute the values, you will get a h of z. Better but here more values are there. For a sample, I will give b0 z power minus 4 plus b1 z power minus 1, b2 z power minus 2, like that. Last one b10 power minus. So what is b0 value? b0 is nothing but 0.060. Z power 0 anyway 1. b1 is minus 0.5 z power minus 1. Like this, b10 0.0 z power minus. This is answer. So we can stop here. If they want to show the structure also we have to show. That structure how to draw, I will explain in it. So what is the problem? Design a low pass filter using Fourier series for the following specification. With the help of this data, initially we then n, then h of n formula for a low pass filter. Simplify, then find out h of 0, h of 1. From that find b, then h of z. This is how we can finish the problem. Now let us look at another important one. Design a band pass filter to pass the frequencies in the range 1 to 2 radians per second using Hanning window with a pipe. Draw filter structure, sampling frequency 1 samples per second. So what kind of filter? Band pass filter. Lower cutoff 1, upper cutoff 2, Hanning window mentioned, N5 given. Filter structure also we have to show, sampling frequency given. So since band pass filter, what is the solution? H of n equal to by ohms is common, but we have to integrate from minus ohm u upper limit minus ohm lower limit. In this range it is 1 to e power j ohm n ohm plus then ohm L2 ohm u is not mu, it is u. Again 1 into e power a ohm b ohm. This formula is important because what is asking band pass filter? Band pass filter from year to year, from from here to here. This is minus ohm upper limit u minus ohm lower limit. Positive side ohm u ohm. So here it is ohm. And in this range it is. So minus ohm u to minus ohm L, its value is ohm upper limit. This is lower. So lower to upper, again it is. This integration carefully you have to do it. So let me derive this. So 1 by ohm, because if I give suddenly ready-made answer, some of the students are do it. So I am doing fully. So what is the integration here? E power j ohm n by ohm nt. What are the limits? Yes, ohm u to yes plus e power j ohm nt. Here j will come. Here also j, because we are integrating with respect to ohm. Limits are here ohm L to those. So this we have to simplify. But 1 by ohm e power minus j ohm L n minus e power minus j ohm u j n plus e power j ohm u e minus power j ohm L by j. We can modify this as 1 by ohm. Here j is there. By combined upper limit. This and this I am combining. Power j ohm u n t plus e power minus j to by 2j. 2j, 2 I am taking, so 2 taking. And nt as it is. Plus here also 2 by n. So which are over, this term is over, this term is over. Now remaining here minus e power j ohm L n t minus e power J O N by 2G. Which is equal to 1 by OMS. This will be sine function sine ohm u nt. So this 2 we can take it out here, minus n sine ohm L nt by nt. So if we simplify this, this final answer I am giving. This is 2 pi fs, so t replaced with s, like that is simplify. You will get n pi sine, this upper frequency is 2 and t is 1. You will get to sine 2n. What is lower frequency? 1. What is t1? So sine n. This is expected. This equation is important. Or if you remember this end answer also okay, but you can't believe memory, you should know how to do it. If this generalized procedure is known, low pass, high pass, band pass, anything, you can do it easily. Now once this is done, find out h of 0. So to find h of 0 here, sine 2n by 2n format you are using. Sin x by x limit extends to form of sin 2n. So denominator also 2n we want, 2 away, so here 2 pi minus sin n, so denominator already n, so 1 by. What is this value at 0? 2 by pi minus 1 by pi equal to 1 by pi. So 1 by pi is 0.31. Then h of 1. H of 0 is tough. H of 1, 2 directly you can substitute. So I am giving answers directly. H of 1 is 0.02 minus 0.2. So 1, 2 up to this sufficient because n equal to 5. Right side 2, left side 2 is equal to h of minus 1 equal to h of. So total we got, as earlier we are already Hanning window n equal to 5 given. So that's why because of 5 h1 h2 sufficient. H of minus 1, h of minus 2, h of 0, total 5 we got it. Now using Hanning window. What is the window function for Hanning? Alpha minus 1 alpha cos 2 pi n by n minus 1. So all these window functions you should remember. Hanning alpha is 5. So this will be 0.5 minus again 0.5 cos 2 pi by 5 minus 1 is 4. Now find out WG. W0 is how much? Cos 0 is 1. 0.5 minus 0.5 is 0. V of 1, it is pi by 2, cos 90, 0. So you get then V of 2, here cos 180, so 0.5 plus 0.5 is 1. W1 value, W minus 1, C. This is anyway same as that. Now we want to find increment in the window. H prime 0, prime 0 equal to H of 0, W of 0. What is H of 0? H of 0, 0.318, but W of 0 is 0. Into 3 is 0. Like that, H prime of 1, that is H of 1, W of 1, that we will get 0.01. Firstly, H prime of 2. Similarly, if you do it, minus 0.226 is the next step. Bi prime is equal to prime I minus m. So m is 2. M is 2. So H prime I minus 2. So this we have to expand. So what is B0 prime? Prime minus 2. What is H prime minus 2? 5. Is B1 prime H prime minus 1. H prime of 1 or minus 1 same. So 0.01. B2 prime H prime of G, that is 0. B3 prime H prime 1. Prime 1 or minus 1 same. 4 prime of 2 minus 0.2. Now we want H prime Z equal to 1 to 2m is 2m 4. Bi prime Z power minus. So this we have to expand. So after expansion and substitute, you will get minus 0.0.0 power 0.3 minus 0.226 -4. Now we have to show the polynomial. We have to show the structure. How the structure looks like. Coefficient multiply minus 0.2 0 z power minus 3 coefficient 0 to 1 minus 0.265 is output to y of n. This output to x. So this is what this answer. And we don't have any denominator, so feedback will not come. Denominator is implemented using feedback. Numerator is implemented using only forward direction. So refer digital filter structure implementation in the previous videos if it is not. So let me summarize this problem. Design a band pass filter to pass the frequencies in the range from 1 to 2 using Anning window n equal to draw the filter structure, sampling frequency given. So this is generalized h of n formula, and integrate, simplify, you are getting this formula. This is important. Using this, find out h0, h1, h2 because window order is given. Anning window, take alpha point. Find out window coefficients, multiply 1 to 1. You will find out h prime 0, h prime 1, h prime 2. From this bi prime you find out. Then h prime z, get the polynomial for this step. This is the solution. So all these things you have to do fastly within 15 minutes. So I hope you understand the I'm slowly writing and explaining so that below average student. Band pass I have done, low pass I have done. High pass you can do. Band stop you can do. Different windowing you can. So these two are the best models. So if you practice and I'll stop.